for failure because I didn't give you the details, but it looks like once you got that detail, most of you were able to figure it out. So let's go through the first part, which is taking us back to when we started this unit and we saw a force body diagram and thought, what the heck is Mrs. Anhire talking about? Now we're pros, right? Because once the person lets go of the ball, we've got no applied forces onto it, assuming that air resistance is negligible, which I told you it was. But we have one long-range force, which is the force of Earth. Now, I didn't tell you at what point in its trajectory to draw this force body diagram, but if my object is falling downward, it looks like this. If my object is being thrown and is traveling upward, does my force body diagram change? No, it looks exactly the same. If my ball is at its peak of its trajectory, does my force body diagram change? No, it is exactly the same. How is that possible if the object is moving upward, not moving at all, and then moving downward? How is it possible that that force body diagram stays exactly the same? Any thoughts? Jacob?
No matter what the instantaneous velocity is, it will always be acceleration.
No matter what no matter at what rate it's being thrown at, it's always going to slow down as it moves upward. It's going to change direction. That's acceleration, changing direction at its peak. And then it's going to speed up coming downward. So that downward force of the Earth is what slows the ball down when it moves up, and it speeds the ball down when it comes down. So let's talk about, any questions? Okay, let's talk about this scenario. The initial velocity is 15. When we did the worksheet yesterday, the initial velocity was always 0 because we always dropped it. We never threw the ball down or never threw the ball up. So this is a new scenario. If I am throwing the ball upward, its final velocity at its peak, this group said 0 meters per second squared. What do you guys think?
Yeah. Wouldn't it just be meters per second? But it's still 0, right?
Very close. It is 0, but it's not meters per second squared. It's meters per second. So units are very important. The other thing I want to point out is the acceleration, no matter where it's traveling, upward or downward, is always negative 9.8. So when they did meters per second squared, it's always going to be negative 9.8, no matter what. And then their explanation was the Earth's gravity balanced the initial force of the throw, causing the ball to have a velocity of 0 until it starts falling back down again. So, good. So this is a good explanation. As the ball's being thrown up, all that energy is being absorbed or is transferring into the height, and then gravity pulls it back down. So we've got the object momentarily at rest at the very peak of its trajectory, which means final velocity this time is 0, and initial velocity is a high speed. And it's positive because it's moving in the positive direction, upward. How far does a ball travel when it reaches its peak? That means displacement. Anytime you see the word how far, you want to think about delta x. Anytime you see the words how long, you want to think about time. So those terms students often get mixed up, and I want to make sure that you have that engraved in your head when you're doing word problems. And this is not going to be up on the board when you take your test. So make sure that you understand that. Delta x is what we're solving for. This group forgot to do their given steps, so I would say maybe -1 point for not showing work. For the kinematic equations, I am requiring the guess method. Trust me, it'll help you. Okay? So my givens are the fact that we've got an acceleration of negative 9.8 meters per second squared because it's on Earth, and that's going to be the acceleration for any free fall problem. And any free fall problem relates to an object that has just the force of gravity acting upon it and nothing else. So we've got the initial velocity given as 15 meters per second in the positive direction. We came up with the fact that the final velocity at its peak is 0 meters per second, and our unknown is equal to delta x. Now that we're given A, so this is a good kind of hint that you can use. We've got acceleration, the initial, the final. We're solving for delta x, and we do not have time. The equation that doesn't have time, oh, I erased it, is the last one. The last one in your physics helper that is under non-constant velocity equations. This group decided to do a multitude of steps, which is totally okay. If you did this step first, solve for time, then you can plug it into any of the three equations. And so, or actually not any three, you would want to plug it into the delta x equation. So the last two equations to solve for delta x. So I like that this group showed this step because it'll be a two-step process, but it'll still give you the solution if you use this and then plug it into equation 2 or equation 3. In the end, this group realized, oh no, I don't need time at all because I can use the third equation. So if you went straight to the third equation, plugged in the values, you would end up with a negative 11.48 meters. Sorry, not negative, positive 11. So usually when we worked on our worksheet yesterday, we got negative displacement values. This time we got a positive. Does that make sense to have a positive displacement? Yes, because this time it is going up in the positive direction. Question, Jehu.
Like the unknowns you have, like that's fine.
Oh, yeah. If you show your givens and unknowns in a method that you've used, that's fine. But I do want to see the steps of writing it out. Tomar.
For the second equation, x equals 1/2 at squared plus bit. Is that initial velocity? Is it plus initial velocity times time? This is like bit. This is for just like a random question.
Yeah. So we have
The second one.
plus v initial times time.
Yeah. So would it be times time or is it just the initial? What's that mean?
No, it is multiplication. It's v, the subscript is part of the velocity because you need to know whether it's initial or final, and then you're multiplying it by time. Yeah, so don't let those subscripts confuse you. They're part of the v variable, which is velocity. Okay, we've got any questions on problem number 3, the calculation problem. This is really what you're going to do on your test, not all that other stuff. Okay, last but not least, we've got question 4. Draw a position, velocity, and acceleration graph for a object that is being thrown up and being thrown down. This is perfect. Now, you want to show that it's moving in the positive direction and slowing down at its peak. And then when it's at its peak, it starts slow but starts speeding up in the negative direction. So it's got a negative slope. The velocity time graph is positive when it's moving upward and negative when it's moving downward. And it starts fast. This is when it's at rest at its peak. And this is where it's moving downward fast. And then last but not least, it is all a negative slope. So it's going to be in the negative side of your axis. And it's going to be a perfectly horizontal line. This was in your second worksheet. And I didn't tell you this, but it is the exact graph you would have for an object that is in parabolic motion. I'm going to go over the directions. It has to be turned in the day of the test, unless you have some sort of, you weren't here on the test or you weren't here on the review day or anything like that. It is absolutely due on Monday for you guys. Anything later than that has a 20% penalty, and 20% on 124 is a big loss of points. So I am not stamping on the test day. You need to show me that you have it completed before Monday, so you can get your stamps today during class, tutorial, or tomorrow tutorial. And I'll even be here early on Monday if you need to get extra stamps before class. Once the bell rings, no stamp, no credit. So even if it's complete, and the only exception to that would be your review worksheet because you need more time to work on that. Everything else, except for the review worksheet, needs to have a stamp before you come in on Monday. And it doesn't matter if it's complete. If you don't get a stamp for it, it's going to be a 0. Second thing, any incomplete assignments will receive a 0. So you want to make sure that if you have a worksheet half done, you're not going to get a stamp for it. And if you accidentally get a stamp for it and I see that it's incomplete, I'm going to remove the stamp and I'm going to give you 0 out of 10. So make sure that you understand worksheets are all or nothing. Okay? And then last but not least, you want to accurately grade your own packet. You want to include the extra materials, notes, which are from physics classroom, the review worksheet, which you're not going to need a stamp for, but you're going to get it done. And then the warm-ups, we have 9 total, which is 18 points. You already got points for your lab along with your graphs. So it's 2 points for that, but I want to make sure you're studying all of this information along with the worksheets because I always put in either a CER or a lab question on the test. So keep that in mind as well. And then those are worth 2 points each. The score has to be calculated by you. I use that as an opportunity to just quickly verify that you calculated it correctly. And then the reflection questions at the bottom, a lot of you just forgot to do that. So total is 124. Jacob. Yes, I'm going to stamp today's warm-ups while you're working throughout the remainder of the period. Any other questions? I just want to talk about 2 more things and I'll let you all work. The homework for today on Canvas has the review worksheet and the answer key. It has to put your packet together and to prepare for the test. So if you click on the prepare for the test, you'll have an outline of what you can study, kind of like a study guide. And then here, under extra resources, you've got an extra credit practice test. You'll get 5 extra credit points if you get all of those questions correct. If you don't, you'll get a portion of the 5, which is still worth a lot. That's a whole 5%. So let's say you got 76% on the test. It'll move you from a C+ to a B-. So I encourage you to do that. And then the other thing I want to emphasize is that I don't take notes in class, but in your agenda every day, I include slides of notes that are important concepts for you to know. So scalars and vectors, distance and displacement, speed and velocity. I talk about the equations, where they came from, graphical analysis, which is a huge portion of your test. And then we get into sort of the kinematic curves down here at the bottom. Actually, here it is. Kinematic curves down here at the bottom where it talks about how to use your equations. Some hints and tips and tricks. So for those of you who like to take notes, learn from that kind of repetitive writing it down, these are available for you to use as a study guide as well. Okay, any questions? All right, go ahead and the remainder of the period, you're going to work on maybe reflecting on your quizzes, working on your review worksheet, and getting your packets together. I've got